going to talk about electric power. Now, one of the things I want you to remember is that power is power. So when we learned power before, and we talked about James Watt and the steam engine, power is still measured in watts, okay? But now we're talking about electric power. So the power rating of an electric device is found by multiplying the voltage by the current. So power is equal to I squared R. Power is also equal to IV. And this is because when we look at Ohm's law says V is equal to IR. That was Ohm's law. This was voltage is current times resistance. So what happens is, over here, let's say I have this equation for power. This is from your book, P is equal to IV. If I substituted in, for the voltage, if I substituted in IR, then I would get I squared R. So when you think about power, there's more than one equation for power depending upon what you're given. Are you given the current I and the resistance? Are you given the current and the voltage? And also, if you were also given the voltage and the resistance. So if you look on the back of your homework sheet here, I have the three equations for power. So power is equal to IV, power is equal to I squared R, and power is equal to V squared over R. So again, this one is I and V, current and voltage. This one is current and resistance, and this one is voltage and resistance. So it all depends on what you're given, but they're all power. Now, I usually remember this one, and then I use Ohm's law to substitute in, or you can remember all three. Okay? So that's what power is. So again, power varies directly with resistance, if we look at it here. So the total energy supplied to any device is the power and the time. So you might have heard something about, like, if you get an electric bill. Well, you don't pay your electric bill. But anyway, usually watts, as we learned before, watts are really tiny, so a lot of times they might express things in kilowatts. So kilo, again, is 10 to the third power. And when you pay your electric bill, you're paying for the electric energy, not the power. So a kilowatt hour is equal to 3.6 times 10 to the 6 joules. Now remember that a watt is a joule per second. So here's just in your notes two different examples, but instead of going over the examples in your notes, what we'll do is we'll just work one or two from the homework real quick, and they're super easy. All right. So we're going to do practice E. Which is electric power, and which is over here. And we'll start off with number 1. So we're going to write our given. We're going to write our find. And again, this is all about just, if I write the given and the find, then I know which power equation I want to use. So it says a 1050 watt electric toaster. So they're giving me the power, 1050 watt. Operates on a household circuit of 120 volts. So that's V, the voltage. What is the resistance? I want to find R. So I want to say, well, which equation has P, V, and R in it? So that equation is P is equal to V squared over R. And because I want to solve for R, I'm going to rearrange the equation to solve for the unknown in terms of the known. Okay? So when I do that, I'm going to have R is equal to V squared over P. I substitute in 120 volts squared over 1050 watts, and I end up with my resistance 14 ohms. And this is how easy the 5 homework problems are. Okay? Let me just see if there's one with a different equation. I mean, they're just using the power equations. This is how all 5 of them are, so you don't really need me to do another one. So you can literally do this homework in like less than 10 minutes. Okay? That's it.